Hello everyone. In this video we are going to discuss the difference between electric field vector and electric field lines. Let us take a point charge Q and a reference point P, and this point P is at a distance r. Then the electric field at point P is given by this expression, and the direction of the electric field is given by the r cap. Suppose if I place this point charge at the origin of an xy plane, and we divide the xy plane into different grid points, then using this formula, we can plot the electric field vectors. While drawing these electric field vectors, the magnitude of the electric field is proportional to the length of the arrow, and the direction of the electric field is represented by the orientation of the arrow. And as we go far away from the point charge, the electric field magnitude will decay as 1 by r square. Now, when we want to draw this electric field vectors, first we had to divide the given space into different grid points. Then at each and every grid point, we had to calculate the magnitude as well as the direction of the electric field vector. Then we represent it with an arrow. Now this representation of the electric field vectors, it's a quantitative representation where we know the idea of the magnitude as well as the direction. Now there is an alternate way to represent electric field. That is what we call as the electric field lines. Now this is a qualitative representation of electric field vectors. Now the next question is, in this electric field lines representation, what will be the magnitude and the direction of the electric field vector? In electric field lines representation, the magnitude is proportional to the density of the field lines. Suppose we have a point charge Q, and let's say this is the electric field lines. If I consider 2 points, point P and point Q, then we can see that the density of field lines at P is greater than the density of field lines at Q. So we can say qualitatively that electric field at P is greater than electric field at Q. What about the direction? Now the direction is given by the tangent at that point. Suppose this is a electric field line, and at point P we want to know the direction of the electric field vector. Then what we have to do is we have to draw a tangent at the point P. This gives the direction of the electric field vector at that point. Now the next concept which I want to discuss is how many lines can we draw. Suppose if we take a plus Q charge, and theoretically or ideally we can draw infinite number of lines, but for the sake of representation, let's say I have drawn 16 lines. Then if I want to draw the electric field lines for another point charge, let's say that is twice of the previous one, then I have to draw 32 lines, because the magnitude of the charge of the second one is twice that of the first one. In summary, the density of the field lines is important, not the number of the field lines. Now if I have a negative charge, then the electric field lines will look like this. But if I have a system consisting of a positive charge and a negative charge, then the electric field lines will look like this. Because the electric field lines, they originate from positive charge and they end at negative charge. There is one more interesting property of electric field lines, that is, field lines can never cross each other. To understand this, let us take one example. Let's say we have a field line number 1, another field line number 2, and they are intersecting at point P. Now, if I want to find the net electric field at point P, then we have to take the vector sum of electric field d21 and electric field d22. Then we will get the net electric field. But this net electric field has a single direction. Now, if I consider the electric field line 1, then I can draw a tangent. If I consider electric field 2, then I can draw another tangent. So here we can see that there are two tangents at point P. If there are two tangents, means there are two directions, and this is not possible. So electric field lines can never cross each other. Now let us summarize whatever we have learned. Electric field vectors, they are quantitative representation, and electric field lines, they are qualitative representation. Electric field lines are not physical entities, rather it's a kind of a visual representation. The density of the electric field lines is proportional to the magnitude of the electric field vector. The tangent at the particular point gives the direction of the electric field, and field lines cannot intersect. Thank you for watching, and if you want to see more such videos, kindly subscribe. Thank you.